You have seen what Joule derived as H is equal to I squared RT. So now let us go to the theoretical derivation of the energy expended in a circuit. So what do you mean by electrical energy? Electrical energy is the energy expended by the current in a circuit. So let us take an example. Let V be the potential difference that is applied in a circuit. I be the current flowing in the circuit. R is the resistance in the circuit. Then Q be the amount of charge flowing in the circuit in a time t. So let us imagine such a circuit. So the first equation that you can write is whatever may be the current that already you know it is Q by T. Or what is Q from this? It is I into T. Let this be the first equation. We know that a potential drop is there or a potential difference is there across the resistor, or a battery is there with a potential difference of V, and it must do some work to drive these charges. So can we write that this potential energy V is equal to W by Q? So children, W by Q. So this W is the work done by the battery, or it is the electrical energy expended by the current to flow through the circuit. So can we write this as E by Q because work is equal to energy? Then what is Q, children, from the equation? It is E by I into T. So we will get a new equation like potential difference V is equal to E by I into T. That is, the potential difference V is equal to energy by I into T. So what is the electrical energy expended? E. E is equal to, we cross multiply this term, we will get E is equal to V into I into T. So this V into I into T is the electrical energy expended by the battery or the work done by the current in moving the charges through the circuit. So what is the equation that we have derived, children? E. Energy E is equal to V into I into T. And we know this energy E is manifested as the heat in the resistor or the conductor. So can we write instead of E as H? So H is equal to V into I into T. This is the first relation for the electrical energy or the heat energy expended or the heat energy produced in a conductor or a resistor. So we can write this in terms of R also. We know that according to Ohm's law, V is equal to IR. So can we write instead of this V as IR? So what will we get? H is equal to, instead of V we will write IR. So IR into I into T. So what is it finally? I into I. It is I square RT. Is this the same Joule's heating law that we have derived? So H is equal to I squared RT. Then, so H is equal to VIT. So this is in terms of V and I. This equation is in terms of I and R. So can we get a relation in terms of V and R? So what is it? Instead of this I, we will write V by R. So what will we get? Equation is converted like this. H is equal to V into, instead of this I, since we know V is equal to IR, instead of this I, we will write I is equal to V by R. So I is equal to V by R into T. So what is the third equation that we are going to derive? It is V square by R into T. This is the third relation. So once again, we will sum up the relations. Children, for the heat energy produced or the electrical energy expended by a battery, which are the three relations? Tell me. H is equal to V into I into T. Heat is equal to potential difference into current into time. H is equal to I squared RT. And H is equal to V square by R into T. These are the three relations that we must do during a numerical analysis to find out heat, depending upon which all factors are given to you. Hope you have understood. See you with more concepts in the next class. Thank you.